Number 38 has a bunch of parts here. Consider the given electron dot symbol for the following element. And you're asked a bunch of questions. So here's an electron dot symbol. Now these dots, this is called the Lewis dot symbol or an electron dot symbol. These dots right here refer to valence electrons. Okay, the dots are valence electrons or outer electrons. Now it's pretty easy to know how many dots an element or an atom gets. So if you're looking at the periodic table and you want to write the electron dot symbol for a particular atom, you simply look at its group number. Okay, the easiest way to do it would be to look at its group number. Now don't use the 1 through 18 numbering scheme. You use the A's and the B's. Okay? So group 1A, all of these guys, all of these atoms in here get symbols that look like this. So we'll just put, Z, and it gets 1 dot. Okay, an example would be lithium. So the electron dot symbol would be lithium has 1 dot. Okay, or you could write it for sodium. Sodium gets 1 dot. Okay, now I know lithium has 3 electrons, but only one of them is an outer or valence electron. So the dots, the valence electrons are the outer electrons. The other 2 electrons of lithium are inner electrons. Okay, so that you remember the electrons occupy shells around the nucleus of an atom. So the valence electrons are the outer electrons. So what about group 2A? Well, group 2A is right here. All of these atoms have 2 outer electrons, and the symbol would look like this. You would get 2 dots. Doesn't really matter, if the dot goes here and there or here and over here. Just 2 different parts. There's like 4 sides, and so you just pick 2 here and there. Okay, so an example would be magnesium, maybe. So the electron dot symbol for magnesium would be like that. Okay, and then going over, skipping these B elements, you hardly ever write electron dot symbols for these guys down here. Just the main group elements, the tall portions. So groups 1 and 2, and then continuing on in the A's. So here's group 3A. All of these guys get 3 dots. So it would look like Z1, 2, 3. An example would be aluminum. Al, 1, 2, 3. That would be the dot symbol for aluminum. Carbon is in group 4A, so these get 4 dots. So 1, 2, 3, 4 looks like that. So carbons would be 1, 2, 3, 4. And then nitrogen would get 5 dots. 1, 2, 3, 4. Go back and pair it. 5. Okay, so it looks like that. An example would be nitrogen. 1, 2, 3, 4. Go back and pair it. 5. So that's the dot symbol for nitrogen. Might as well finish off 6, 7, and 8. So 6, we'll just do an example. So oxygen is in group 6, so it would look like this. 1, 2, 3, 4. Go back and pair it. 5 and 6. Okay, and then fluorine or chlorine is in group 7A. So we'll do, how about chlorine? Chlorine would look like this. 1, 2, 3, 4, 5, 6, 7. Okay, and then finally, group 8A is filled up. Okay, so how about neon, for instance? Neon would look like this. 1, 2, 3, 4, 5, 6, 7, 8. Now all the sides are paired up. And that's kind of how you can do the dot symbols just by looking at the group numbers on the periodic table. So I think that'll help us answer this question. So what is the first one? Okay, let's highlight these questions. What is the group number of Z? Okay, so here's the dot symbol. Z has how many dots? 6 dots. So that's telling us that it's in group 6A. It's in oxygen's group. Okay, the group number is 6A because it looks like it looks like oxygen. Okay, so I would put for A is group 6A. Group 6A, and then how about B? Okay, what is the charge on the ion formed from Z? Okay, the idea here is that is it easier for this to gain electrons to be like a noble gas or to lose electrons? Well, this already has 6 electrons, 6 valence electrons. And look how many the noble gas elements have that are in group 8A. So the noble gases have 8 dots. Okay, neon, for instance, has 8 dots, and this already has 6. So it's easy for this to gain 2 more electrons. So if it gains 2 electrons to look like this, 1, 2, 3, 4, 5, 6, 7, 8, then that means the charge would be -2. Okay. Now, if you only had somebody like magnesium, this has 2 dots. Well, it would be easier for magnesium to just lose these 2 electrons to be like the previous noble gas, and it would have a charge of +2. Okay, but when you're starting with somebody like this that's already got 6 dots, it's easier for it to gain 2 electrons to be like a noble gas. Okay, so the charge for this one in this case would be it would gain 2 electrons, and that would give it a charge of +2. Charge equals -2. -2 because it gains 2 electrons. Okay, what's the next one? C. What is the formula of an ionic compound formed from Z and sodium? Okay, so you got, say, sodium, and then whatever this guy is. Okay, sodium and this guy. Well, this guy has a charge of -2. So let's think about this. Okay, you have Z. Z, if it forms an ion, it'll be -2 charged ion. Now, what charge does sodium form? Sodium's in this column over here. Okay, so sodium looks like lithium. They're in the same column. It would be easier for sodium to lose 1 electron. So sodium would have a charge of +1. And if you don't believe me, look at the periodic table on sodium. Where is it at? There it is. The periodic table which tells you the charge that sodium forms. Sodium's in the +1 column. All of these guys, if they form ions, they simply lose that 1 electron. And those guys, of course, would lose their 2 electrons. Okay, so sodium is a +1 ion. So you have a +1 and a -2. Now, the way you form an ionic compound is you have to have the same number of cations as you do anions. So right now, or you have to have the same amount of charge. I mean, right now it's +1 and -2. That doesn't balance. Okay, so you need 2 of these sodiums to balance the -2 on the Z. And the formula, I guess we could say, is Na2Z. Okay, that's, I think, what this problem is asking us for. The last one is, last one is D. What is the formula of an ionic compound formed from Z and magnesium? Well, magnesium's got a +2 charge. So this is D. I'm sorry, D. Let me move that up. So this time you got magnesium, which likes to form +2 ions. And magnesium and the -2Z already balance out. So you don't need 2 magnesiums to balance the Z. They already balance. And so the formula is simply MgZ. Okay, and there you go. You just need one of each.